Okay, just imagine this for a second. What if you could send a text message just by thinking it? Or what if you could move a robotic arm with nothing but your mind? Well, that's not science fiction anymore. Today, we're plugging right into the incredible science of brain-computer interfaces, a world where thought literally becomes action, like instantly.
And to really understand what this is all about, you just have to hear this quote from Caroline Gorham about her husband, Rodney. His body's disintegrating, but his brain is staying the same. Wow, I mean, that just hits you, right? It's such a powerful reminder that at the heart of all this futuristic tech, we're talking about real people. People with minds that are still vibrant and full of life, just looking for a way to connect with the world again. All right, so here's the game plan for our deep dive today. First, we're going to look at some of the miracles that are already happening. Then we'll get into the nuts and bolts, like how do you actually read a thought? After that, we'll jump into the big debate over the best way to do this, uncover a really tricky paradox about the brain itself, and check out this incredible digital bridge that's helping people move again. And to wrap it all up, we're going to look to the future and ask the big question. What does this future inside our own heads actually look like?
Okay, let's kick things off with the incredible, life-changing impact this tech is having right now. Seriously, for people dealing with severe paralysis, this isn't some far-off sci-fi dream. It is a lifeline. So this is Rodney Gorham. He has ALS, and he's had his synchron stentrode implant for, get this, a record-breaking 1,600 days. So how does he use it? Well, with a mix of eye tracking to move a cursor and the BCI to click, he can do all sorts of things. He can send texts, he can browse YouTube, he can even, playfully flicker the lights to get his wife's attention. And that's the key, right? As his wife says, he can still express his personality. He can be Rodney. It's about bringing him back. Okay, so how in the world does a thought, just a thought, turn into a click on a screen? I mean, it really does seem like magic, doesn't it? But it's actually this brilliant mix of biology and engineering. So let's pull back the curtain and break down how you actually read a thought. So at its most basic level, a BCI is, well, it's pretty much exactly what it sounds like. It's a direct line of communication between the brain and a computer. It completely bypasses the body's usual wiring, the nerves and the muscles, and just lets the brain talk straight to a device. You can almost think of it like a mental remote control. And the whole process really boils down to three main steps. It's pretty straightforward. First, you have to record. Tiny electrodes listen in on the electrical chatter happening between your brain's neurons. Next, you have to decode. A controller, which is usually powered by some pretty smart AI, looks at all those signals and tries to figure out your intention. What are you trying to do? Are you trying to move a cursor left or right? And finally, step 3 is command. The system takes that decoded intention and turns it into an actual command for a device. So, record, decode, command. That's the basic loop that turns a thought into an action. All right, so as you can imagine, there's a huge race going on. You've got companies like Neuralink and Synchron all rushing to perfect this technology. But this has sparked a massive debate in the field. And it all boils down to one really fundamental question. What is the best way to listen to the brain? And this debate really breaks down into two main camps. On one side, you've got the invasive approach. Think Neuralink. They surgically implant these super thin threads directly into the brain tissue. The upside? You get an unbelievably clear, high-quality signal. The downside? Well, it's open brain surgery. Then, on the other side, you have the less invasive camp. This is where companies like Synchron come in. They place their sensors inside a blood vessel next to the brain. It's way, way safer. But the signal isn't quite as sharp. And that, right there, is the central trade-off everyone is wrestling with. Do you go for the highest quality signal? Or do you prioritize safety? But, this whole challenge goes way deeper than just the hardware. It's not just about where you stick the electrodes. It's about figuring out what in the world you're actually listening to. And this is where we get to a really fascinating puzzle. So scientists have found this weird paradox inside the primary motor cortex. We can just call it M1. That's the part of your brain that basically shouts out the commands to move your body. And the paradox is this. M1 has both too little and too much information at the same time. How does that work? Well, it's too little because M1 is just one piece of a much larger network that creates movement. But it's also too much because that pure move your arm command gets all tangled up with a bunch of other brain signals. Things like, are you paying attention? Are you getting feedback? All of this extra chatter, it's like trying to hear one person's whisper in the middle of a loud party. And all that noise can really confuse the BCI's decoder. So if it's like a loud party, how do you isolate that one whisper you're trying to hear? Well, the solution is actually pretty brilliant. Instead of trying to ignore the noise, you listen to the entire party. By recording from other parts of the brain, the parts responsible for things like attention and feedback, an AI can learn what that noise sounds like. And then it can digitally subtract it from the main signal. It's like noise-canceling headphones for the brain. What you're left with is a much cleaner, much purer motor command for the BCI to work with. Okay, but what if we could take this a step further? I mean, controlling a computer is amazing, but what if you could reconnect the brain to the body itself? Now we're talking about the next and, frankly, incredibly ambitious frontier in this field. The idea here is nothing short of revolutionary. The goal is to build a digital bridge, something that can completely bypass a spinal cord injury. It would take the movement commands straight from the brain and send them directly to the muscles, effectively restoring control over a person's own arms and legs. And the most amazing part? It's not just a theory, it's actually happening. Researchers in both Switzerland and China have built these brain-spine interfaces. Take Gert-Jan Oskam, for example. He was paralyzed for 12 years after a bike accident, and now he can stand and walk again. It works like this. An implant on his brain reads his thought, his intention to walk. An AI decodes that thought in real time, and then a second implant, this one on his spine, stimulates the precise muscles needed to take a step. It's literally a digital bridge for his brain signals, built right over the spot where the original connection was broken. Just incredible. So these breakthroughs are obviously life-changing for patients, but, it makes you wonder. It naturally leads to that big question. Where does all of this go from here? Is this technology ever going to move beyond the hospital, beyond therapy, and into our everyday lives? Well, some very smart people are betting big that it will. The CEO of Synchron, for instance, he predicts that by the 2040s, you could get an elective BCI for about $40,000 to $50,000. I mean, we're talking the price of a new car. Just think about that. You could be typing an email while mentally queuing up your next song, or designing a complex 3D model with the speed of thought. This isn't just about better multitasking. This is about completely changing the way we interact with computers and with the world. But, and this is a huge but, this future also brings with it some of the most profound, most complicated ethical questions we have ever had to face. I mean, think about it. If we give a corporation access to our raw brain data, who owns our thoughts? Is it us or is it them? Could an algorithm running inside your own head, as one CEO warned, learn how to exploit your subconscious vulnerabilities? And what about society? Could this create the ultimate social divide? A world of the neurologically enhanced and everyone else? And really, that's the ultimate question we're left with, isn't it? As we stand right on the edge of merging the human mind with the digital world, a step that could unlock potential we can't even dream of yet, who will you trust with your thoughts? It's something we'll all need to think about. Thanks so much for diving into the future in our heads with me today.